Because it could fall out at any time. I can just lose control of my car.
All right, let's see here. 27. Find the product. Now, as I discussed with you on Friday, I am probably not going to give you... This involves changing first to polar form, then doing the multiplication. I would rather have two separate questions. One where you change to polar form, and a separate question where you actually do the multiplication. All right? Because if you mess up the polar form, you've automatically messed up the multiplication. So 3 minus 2i. So we'll do question 27 here. 3 minus 2i. Or, well, let's see. 3 minus 2i. That's like down here. And 1 plus I. That's like up here. Yeah. I wanted to make sure you guys drew pictures. And I was like, because that's how we end up thinking through what's going on. We need the distance there and the distance there, right? So the first one, what do we got? The square root of what? 13, right? Because you got 3 squared plus 2 squared. We've talked about how you draw your right triangle and just realize you got a 3 and a 2 to find your hypotenuse, which is the radius. Okay, and then we need the angle measurement. Cosine something plus I sine something. So tangent inverse of what? 2 over 3, opposite over adjacent. Okay. So if we invert the tangent of 2 over 3, we end up with 33.7 degrees. That's this angle right here. Okay. But I don't want to put 33.7 in there. What do I want to put in there? Something bigger than 270 degrees, folks. The angle I drew right there is a lot bigger than 270 degrees. How'd you get that 326.3? Yeah, subtracted. Nice job. 326.3. Okay, so now I go to the other triangle. Maybe we should have used a different color. We need this one, which we know that's got a side length of 1 there and a side length of 1 there. So the radius would be what? Square root of 2. Nice handy dandy 45, 45, 90 right triangle. Right, so this one is radical 2 times cosine something plus I sine something. Do you really need to do inverse tangent, or do you know the angle? We know the angle, don't we? It's 45 degrees. And because it's in quadrant 1, we actually use the 45 degrees. But if you didn't know that, you could always do inverse tan of 1 over 1. Okay? Of course, if you're dividing 1 over 1, people are already snickering. You know what I'm saying? Because it's a 45. It is an isosceles right triangle. You've got the legs are both the same. The legs are both 1. So, I mean, even if you do the Pythagorean theorem, right, the 1 squared plus 1 squared, that's how you get your radical 2. But that fits the 45, 45, 90 right triangle. But if you didn't know that, you could do inverse tan and come up with the 45 degrees. Okay, now let's do their question. That wasn't the question. That's why I'm saying that I would not put these things together. I would not ask you to first change 2 things into polar form, then ask you to multiply them together, right? I feel like it's too much for one question. So it would be like on a test, that would be plenty for one question, but they asked me to do more. They asked me to multiply them together. So what do you get when you multiply? What do you do to multiply these 2 together? What do you do with the radii? You multiply them. Radical 26. Next, What do you do with the 326.3 and the 45? You add them. So whatever 326.3 plus 45 is, what'd you get? 371.3. Okay. So cosine 371 point. Oops. Can't. I think I can speak, but it doesn't really look like it or sound like it. Okay, so that's the product of the two. And then they wanted also the quotient. So that ain't it. It's not over. I'm like, come on, this problem goes on forever. Okay, so definitely wouldn't ask you for all of this in one question. Oh my goodness. Click off, please. Yeah. You guys are not trained very well, aren't you? I mean, what do they teach you in advisory? Aren't you supposed to all cough very loudly at the same time to help your friends? Seriously. Oh, now that is harsh, but if that's the reality. What?
We get to spend some good quality time together.
Oh yeah, this next 4 days, man, we're gonna be we're gonna be lots of advising going on. Okay, number 27. What? Why do we multiply the radii together? The formula using de Moivre's theorem says that you would take R1 times R2, and that's how we got this radical 26. Then you have to add the angle measurements to get the 371.3. So that's just part of de Moivre's theorem that we worked on last week. And so now they've asked me to do the division. Okay, it says find the quotient, Z1, Z2. So now I'm going to divide those two things. What do you get when you take radical 13 over radical 2? Radical 13 over radical 2, okay. Probably should rationalize that just for fun, giving me radical 26 over 2. Okay. And then, of course, what are we going to do with the 326.3 and the 45? We're going to subtract them. So if only we knew what 326.3 minus 45 was. 281.3. Oh, that's awesome. The answer to the first question of Z1 times Z2 was right in this. And then cosine 281.3 plus I don't know, 326.3. 326.3 minus 45. 281.3. Do not doubt her. She is right. Okay. Better than throwing down, I guess. Although I'm sure gravity has something to do with it. If you throw up, you probably will throw down. Just saying. Okay, unless you're in a weightless environment. And then you're going to throw all over the place. After that statement, you're hungry? Whoa. All right, folks, that's a lot in one question. I would not put all of that in one question for you. It would be enough to change them into polar form. It would be enough to take two polars and then multiply them together, or take two polars and divide them. I mean, that's like 3 test questions right there, not one. Okay, now, using the standard form, I didn't even do part B. What's the standard form? That means we go back to Algebra 2 and we multiply them together the old-fashioned way with FOIL. Okay? Nah, not going to worry about it. Okay? You guys have already done the Algebra 2 stuff. You don't need to do more of it. Oh, I should undo that. I should copy this. Wait a second. It's probably, yeah, it wouldn't. I can't do it. Oh, man. That's terrible. It's in the video, but it's not on the, it won't be on the document. Okay. maybe if I do this, oh yeah, I could save it and then go into the show in folder. That'll work. Screenshot. I said mouse. Okay.
Well,
Yeah, it is. It's a mess on top of a mess. Here, I'll clear it off so that, you know. Come on, man. How do I... Here, maybe I should just go copy. Then I'll come back to the document. Put that in there and paste. Come on, work. Obviously. Why isn't it? Oh no, I know. It was my, you know, this weekend studying for the test. Where? It'll be right here. Okay, 17. What are they asking me to do on question 17? Why did we put these like right on top of each other?
All right, you know what? I apologize.
You should. Yeah, let's use some good language. All right, so 17, what'd you say it was? Standard form, all right. So we know that we're talking about 7 pi over 6, which is down this direction, right? Drawn around to 7 pi over 6. And we know that the length of that is radical 2. If only we could find these two sides of the triangle. We know they're both negative, right? All right, so how are we going to do that? We can use the unit circle, sure. All right. Do you know the cosine is 7 pi over 6? Yes, negative radical 2 over 2. The last one, it wasn't pasting, so I'll have to go back. It's in the video though. And how about the sine? Negative 1/2. I wonder if we could distribute that radical 2. And if we distribute it, what do we get? Negative radical 6 over 2 plus I. Negative radical 2 over 2. If you really like it, you could put the minus in front of the I radical 2 over 2. Yes, it was that simple, folks. It is just as easy as taking the cosine of 7 pi over 6, which we should remember from our unit circle days, right? 7 pi over 6. It's got to be the one closest to the outside edge and halfway between 0 and the bottom. Yes. Okay, I thought this was going to be like a State Farm commercial. You know, I've learned a thing or two because I've seen a thing or two. You know? Okay, what? Oh, that's farmers. That's right. Yes, sometimes we do overthink problems. I'm not, it's not a joke. I mean, we really do overthink things. And when we look at what we have and what we're really being asked to do, sometimes it is easier than we think. Like question 35. I saw several of you leave it blank or just write down an answer from the answer sheet because you didn't know what to do. I didn't see a whole lot of people graphing it. Where is it? Where is 1 plus I? Yeah, it's the first quadrant. Over 1 and up 1. There it is. 1 plus I. By doing that graphing portion, we can sit there and think about the right triangle and realize that we have an isosceles right triangle. Okay, so what's the radius? Radical 2. So this is radical 2 plus, and then what is the angle measurement? Mr. Query, I think that earlier I said de Moivre's theorem, and I should have reserved that. The multiplication is not, de Moivre's theorem is more like a modification or a useful, they're using the multiplication property. So I shouldn't have used that earlier when we were just plain old multiplying. Here's de Moivre's theorem where we're raising it to a power. So do we have the angle inside there? That is a 45-degree angle. If you didn't know that, you could use the tangent inverse opposite over adjacent to come up with that. It is in quadrant 1, so I don't need to change anything. And I should, so cosine 45 plus I sine 45. Okay, so this whole thing is getting raised to what power? The 5th. So what happens to the radical 2? So we want radical 2 raised to the 5th. And what happens to the angle measurements? 45 times 5. What is 45 times 5? 225. So I think we can keep going with this. This is nice. All right, think about your 225. That's down here. What's the cosine? What's the cosine? Negative radical 2 over 2. And what's the sine? Also negative radical 2 over 2. On the unit circle, remember how... are you saying 225 or where it is on the circle? Okay, so we know that down in quadrant 3, you've got negative 1/2, negative radical 2 over 2, negative radical 3 over 2, and then at the outside edge you got negative 1. And negative 1/2, and negative radical 2 over 2, and negative radical 3 over 2, and negative 1. And since we're dealing with a 45-degree angle here, it's that second one out of the 4. Okay? Now, radical 2 raised to the 5th. What do you get when you take radical 2 times radical 2 times radical 2 times radical 2 times radical 2? You could say the square root of 32, but anybody know that mess right there in the box? That is 4, thank you very much. So we could simplify that to 4 radical 2. Now, can we distribute that in and get some nicer numbers? I bet we can. Okay, don't listen to that kid. All right, now. Okay, 4 radical 2 times the first fraction, negative radical 2 over 2. Anything cancel? Doesn't 2 go into 4? Twice, right? Here, maybe I should write that over here. 4 radical 2 times negative radical 2 over 2. Okay, and so we can start this canceling process. That goes in twice, and then you can get 2 times negative 2. What? As far as the reducing part?
The radical 2 cosine 45 goes with question 35, right? Like the red one?
Correct. This is the original.
Okay.
In the box there is the original 1 plus I written in its polar form. And then we're raising it to the 5th power. So I've got these two radical 2's being multiplied together. I got a negative there, and I got a positive 2. So what do we get when we multiply a negative 2 times radical 2 times radical 2? That's negative 4. Okay, so that takes care of the first part. And then we have 4 times, or 4 radical 2 times that. Man, I need some space. I am. Wow, that is never truer words have been said. 4 radical 2 times negative radical 2 over 2. We'll just throw the I in there. Okay. Anything cancel out? Same thing before, right? So we're going to end up with negative 4i. Okay, so if this is negative 4i, then we had negative 4 minus 4i as our final answer to the question in question. The question in question? Whoa. Amen. Preach it, Brother Zimmel. Okay. Graphing is extremely important. Then we find the polar form. Then we apply de Moivre's theorem and do the reducing. Yeah, I wish that was a little bit better organized. It looks ugly. It is, well, slightly, just because of the way I organized it. If I had organized it better, it would be much better. Yeah. You know I'm right, Coop. You know I'm right. Saw you giving her the eye.
Who the eye?
You gave it to her. Yeah. Rolling your eyes about what I said. Okay. All right. Anything else on 6-6? Homework questions?
37. No, dude.
Post it in the document. What?
Yeah, what time? That's how it is every day. That's Thursday.
Okay, Miss Johnson, what was your question?
Really small. It's for 25. They have, it's a division. They have 6 cosine 5 pi and 3 cosine 2 pi, and they got cosine pi. But I don't understand.
5 pi over 3 minus 2 pi over 3. Wouldn't that be 3 pi over 3? What's 3 pi over 3? Isn't that just pi? That's all they did. I'm sure. Subtracted the angle measurements. All right, I'll try to be a little bit better in how I organize this.
Watch this.
Okay, thank you. So we have 1 and minus radical 3, which is approximately 1.73 down. Years of experience. Okay. You know the the direction. If you wanted to label the sides in radicals, I'm not going to label it with decimals. I just kind of wanted an approximate. So I got 1 and minus radical 3. We can find the radius, right? R equals the square root of 3 plus 1, which is the square root of 4, also known on the street as 2. Radical 3 squared is 3, right? And 1 squared is 1. So that's where we get the 3 plus 1 is 4. And then just take the square root. Okay, the angle inside there, if I do the tangent inverse of opposite over adjacent, what do we end up with? And the negative really doesn't matter. You can throw it out if you don't want to, because you're only interested in the angle inside that triangle. Why do I feel alone in the world? Tangent inverse of radical 3, isn't that 60 degrees? Come on, guys. Can't let go of that unit circle. Ever. No, you won't. Okay. You'll keep steering that steering wheel in your car going, oh, look at all these angles. And you'll never forget. Yes. The unit steering wheel. So, what is the angle measurement that we have there? How are we using the 60 to help us find the real theta? 360 take away 60. 300. Yes. 300 degrees. Okay, now. So we're dealing with 2 cosine 300 plus I sine 300. And what power are we raising this whole thing to? The third power. And so what happens to the radius? That's right. Pop it up to the third. Okay? Like a collar. Okay? And then what are we doing with the 3 and the 300? Multiply. So it'd be cosine 900. Man. It's a roasting angle, man. These marshmallows are going to be fried. So 2 to the third, we got an 8. Cosine 900, where's 900 on this thing? Well, okay, 2 trips around the circle would be 720, right? So where's how much more is that? 900 take away 720? Oh, so you're saying we're landing right here on the unit circle? Do we know the cosine of that spot? -1. Do we know the sine of that spot? 0. It is not undefined. It is definitely 0. Okay, so that's how you ended up with -8. For those of you who wrote down -8 and didn't have all that work. Okay.
The one that I had, I just looked at how you did the first section. 25. I don't feel like
25? That's a division question, right?
Yeah.
Okay, so what all you're going to be doing is dividing the radii. Oh, I don't know. Let me jump over here. You got it entered in? Thank you. Oh, yes, yes, yes. Okay.
Okay, so right here, why did they get radical 18? Because I thought it'd just be 3 plus 3, which would be radical
So
6.
9 plus 9 is 18, and you take the square root.
I thought that would cancel out. And
Okay,
just make
negatives cancel out, right? And then you have 3 times 3, which is 9. 3 times 3, which is 9. So 9 plus 9 makes 18.
Why is it-
Okay, because
I thought you did
you
up
have
on the-
side lengths. You have side lengths of 3 and 3.
Okay.
Doesn't matter what the negatives are. You just use your Pythagorean theorem, right? That's how you end up with the square root of 18. If I just had 2 side lengths of 3, 3 and 3, you just do 3 squared plus 3 squared. So the negatives won't really matter in terms of the radius. Which quadrant it's in, yeah, that matters. Okay, so are they just asking me? What are they asking me to do here?
Well, I have to-
They just want me to divide it? What are they asking me to do in question 23? They just want me to divide those two things together? All right, so what do you do with the 2 and the 3? Nice, we divide. All right, what do we do with the 30 and the 60? Subtract. Right, 30 minus 60 is -30.
Oh, you subtract.
Yep, that's what Demoivre's theorem says. Demoivre's. It's that French one. Okay? Did they want me to go further? Did they want me to simplify this into something or just put them together? I think they just wanted me to put them together. Yep. Okay, that sounded gross. All right.
Oh, wow. That was easy.
What happened to my... The recorder is recorded. Great. Where is it? Why am I not seeing it? That's the question. Create a new recording. I thought I was in the middle. Recorder is recording. Click here to... Okay, so 37, yeah. Yeah, let me see if I can jump back to the picture you're talking about. Is it this one?
Yeah.
Okay.
I think you gave me a fist bump. I did one myself. When you have the one square against the three, you added those in the middle. But I have 6 square. 6 square. So how come I wouldn't add mine?
Okay, are you multiplying or are you raising to a power? I mean, I understand that raising to a power is multiplication, but, all right. Okay, so you have -5 plus 5i, and what power are you raising it to? It doesn't really matter at the moment. Okay, so -5 and 5. So we had, in this particular example, we had 1 and negative radical 3, and so I had to use those to come up with my radius. And you're doing it right. You know, you got 25 plus 25.
I just screwed up.
So this one would be 36 plus 36, right? It'd be square root 72. This is square root 50. I mean, if you want to simplify it, you
I
can.
just wasn't sure because that when you did that, it kind of confused me. So
Okay.
I
We
see
just
what-
came up
I
with a
see
nice
what
whole
you did.
number,
Yeah, I see
whereas
what you
yours did not. That's all.
I don't know why that was.